So what we want to do now is calculate standard deviation for all of our data sets. It's also fairly easy. So what we do is we've already set up here a cell where we want our standard deviation values to go, and now we need to calculate standard deviations for the proboscis length for A. cytherea and A. basiloides. We'll put it here, and over here we'll have body mass for each of the two species. So now what we simply do is click on the cell where we want the standard deviation value to go. We come up here, sorry about that, to the sigma sign again. We call up our formula builder, and you can see I've already been using this before, and standard deviation comes up as one of the most recently used stats from this list. But you can type in STDEV, and up will come a bunch of different variants on standard deviation. You want the one with no suffix here, so you just want STDEV, and you double click. All right, now what you see here, coming back over to the A. cytherea proboscis data, it's highlighting automatically the numbers above it. So right now it's taking the standard deviation of the mean, mode, and median, which is what we don't want. What we want is to take the actual raw data, which is in column C, cell 18 to 32. So we just click here and drag down. Okay, you can see over here in this dark gray box, it just sucked in the cells that we want to cover, C18 to C32, and now it's going to calculate a standard deviation for this value. All you have to do at this point is hit return or enter, and our standard deviation is 2.3 for this data set. Now doing the same over here, again, click on the cell, double click on STDEV. It's doing some auto selecting here, but obviously that's not the raw data that we want. We come back over here, D18 to D32, we highlight all of those, we hit return. And again, you can do this very quickly once you get the hang of it. Calculating standard deviation becomes a breeze. So there we go, small. And then again, double click on STDEV, ignore what it's auto selecting, select the raw data that you want, and hit return. Now we have our 4 standard deviation values. You can see here that A. cytherea has a standard deviation in this data set of 2.3, but the A. basiloides sample, these 15 butterflies that we've sampled, they show greater variability in their proboscis length. The same thing is true over here when we look at body mass. Slightly greater variability in body mass for A. basiloides as compared to A. cytherea. All right, so on our distribution graphs, this would be a broader, more spread out curve for each of these two species. This would be more of a peaked curve, A. cytherea, and for body mass and for proboscis length. All right, good. You should be able to do this now.